So now let's finish off our overview of the way to group together these 60+ methods in the Java CompletableFuture API. And now we're going to talk about exception methods and arbitrary arity methods. So what are arbitrary arity methods? First of all, what does arity mean? Seems like a fancy schmancy word. Arity is just something that means the number of parameters that are accepted. So we're familiar with this from good old C or Java or C# or whatever you use as your programming language of choice to begin with. You have some methods that take one argument, unary method like a unary plus or a unary minus. We have other operations that take two arguments, binary operations like binary plus, binary minus, binary multiplication, binary division, and so on. And then there's actually ternary operators, things like the ternary operator in C, Java, C++, which takes a conditional expression and then does one of two things. What arbitrary arity means is you can have an arbitrary number of parameters going from 0 to n, where n could be very large. So there's two methods that do this, and these methods process completable futures in bulk by creating a single completable future that does something when the other futures complete. And the two methods that matter here are allOf, and as the name suggests, this returns a completable future that triggers when all of the parameters pass complete. So it's all of them have to complete allOf. And then the other one, which will also be pretty obvious when you hear the name, is anyOf, which says I will get back a completable future that will complete when any of the completable futures finish. So whichever one finishes first, then we get a completion. So those are the two typical types of operations you can build using allOf and anyOf. And the completable future that's given back is triggered when all things complete for allOf or when anything's complete or the first one completes for anyOf. We're going to spend a bit of time later, not right at the second, on allOf because allOf is very useful, and when you do programming assignment number 4, you can see we built a collector that will trigger when all the other asynchronous operations stop running, and it's super cool. These capabilities, these arbitrary arity methods, help to make programs more responsive by not blocking calling code. So it makes your system reactive, responsive, and so on. So you don't block waiting for all these things to finish. They can go off and run, do their thing asynchronously, and when they're all done, or when the first one's done, then you're going to be notified. However, these methods are also somewhat complicated to program directly for a variety of reasons that we'll talk about later, and therefore you're best served by using a wrapper of some kind to encapsulate this Gordian knot of complexity, which is what you otherwise end up with if you have to program to these methods directly. The other style of methods are called exception methods. The name again sort of gives away their purpose. They are used to handle exceptional conditions at runtime that occur when operations are running asynchronously. That is the key issue that makes them tricky. You want to be able to do this stuff at runtime and be able to do the processing of exceptions in the right context. These methods are very important because asynchronous exceptions are quite different than synchronous exceptions. I won't go into detail right now about why that's the case, but in a nutshell, when you make a synchronous call, if something goes wrong, the exception is thrown back to the calling thread, which knows the context in which it was called, because it's blocking synchronously. Okay, that's fine. When you have an asynchronous operation and something goes wrong, it's no good telling the calling thread, because the calling thread's probably off doing something completely different at that point. So you need to be able to have the results come back in the right context in order to be able to handle it effectively. So we'll talk about that, and you'll see some examples. These features, these exception methods, help to make your program more resilient by handling these erroneous computations gracefully. So rather than having your whole program come to a screeching halt when one thing goes wrong, instead you can make your program be more resilient by handling only the things that went wrong and maybe restarting them or coming up with some other alternative way to get a result back that might be a default result. At any rate, it allows your program to be resilient to partial failures. So they will handle erroneous computations gracefully rather than crashing and burning. All of the methods we talked about, be they factory methods, be they completion stage methods, be they arbitrary arity methods, be they exception handling methods, all of these things are implemented internally using a message passing framework, and we're going to talk more about how that works. And that gives you loose coupling, isolation, and location transparency. I should have put that in quotes because you're still running on the same processor, but where you run in that processor can be deferred until runtime because things are done by passing messages to a pool of threads. And those pool of threads can be all kinds of different varieties. You can have a cached or variable size thread pool, you can have a fixed size thread pool, you can have a work stealing thread pool. All those things are arranged in different ways under the hood, and you have full control over that with completable futures, whereas with parallel streams, you are limited to the common fork join pool. So that's the end of the discussion of the method groupings for Java completable futures.